Now we can see about channel length modulation, comparison of Mosfet BJT channel length modulation. Here the channel length modulation, it is an effect in field effect transistor, a shortening of the length of the inverted channel region with increases in drift bias for larger drain bias is the result of channel length modulation is an increase in current with drain bias and a reduction of output resistance. It is one of the several short channel effect in Mosfet channel scaling. It is also cause distortion in JFET amplifiers. To understand the effect, first note the notation is a pinch off of the channel is introduced. That is, the channel is formed by attracting of carriers to the gate, and the channel drawn through the channel is nearly a constant, independent of drain voltages in saturation mode. However, near the drain, the gate and the drain jointly determine the electric field pattern. Instead of flowing into a channel beyond the pinch off point, the carriers flow into a subsurface pattern made possible because the drain and the gate both control the current. In the figure, right, the channel is indicated by dashed line, and because weaker as the drain is approached, leaving a gap of uninverted silicon between the end of the formed inversion layer and the drain, that is the pinch off voltage. And also, as the drain voltage increases, its control over the current extends the further towards the source, so the uninverted region expands towards the source, shortening the length of the channel region, and this is called channel length modulation. Because resistance is proportional to length, shortening the channel decreases resistance, causing an increase in current with increase in drain bias for the MOSFET operating in saturation. The effort is most pronounced and the shorter the source to drain separation, and the deeper the drains junction, and thicker the oxide insulator, and this is the channel mode corner length. Here while we are seeing that the weaker inversion region, that is the influence of the drain to channel length modulation, leads to the power device turn off behavior known as the drain introduced barrier lowering and drain introducing the lower of threshold voltage. And also in the bipolar devices, a similar increase in current is seen with increasing the collector voltage due to base narrowing, so known as the Rayleigh effect. And also the current has lead to use of the term Rayleigh effect for MOSFET, as well as the alternating name as channel length modulation. The effect of channel length modulation up to the MOSFET outside resistance varies both with the device, particularly in the channel length, and with the applied bias. And the main factor affecting the output resistance is longer, and that is the MOSFET is channel length modulation is just described. And here in the shortened modulation, additional factors arises such as the drain induced barrier lowering and the velocity substance, and also the plastic transport. And here and also here these are the some of the additional MOSFET factors arises due to the drain induced barrier. That's the channel length modeling. Next one is the comparison of MOSFET with BJT. While we are seeing some of the parameters, first parameter is the full form, that is the JFET stands for bipolar junction transistor, and second one MOSFET is the metal oxide semiconductor field effect transistor, and the definition for BJT is the three-terminal semiconductor device used for switching and amplification of signals. The MOSFET is the four-terminal semiconductor device which is used for the switching application, and the types of BJT are classified into NPN and PNP. Here it is classified into P channel enhancement MOSFET and N channel enhancement MOSFET, P channel depletion MOSFET and N channel depletion MOSFET. And the terminals are emitter, base and collector, and the MOSFET terminals are source, gate, drain and body. And here the charge carriers, in BJT both electrons and holes acts as the charge carriers. Here in MOSFET either electrons or holes acts as the charge carrier depending upon the type of channel between the source and the drain. and the polarity. BJT is the bipolar device and it is the unipolar device. BJT is the current control device and MOSFET is the voltage control device, and BJT has lower input impedance and MOSFET has relatively high input impedance, and BJT has negative temperature coefficient and MOSFET has a positive temperature coefficient. And here the switching frequency of BJT is lower, and here for MOSFET the switching frequency is higher. And here in the case of power consumption, BJT consumes more power than the MOSFET, and the more power consumed by the MOSFET is less than the BJT. And the application is BJT is preferred for the low current application. It is used as amplifiers, oscillators and electronic switches, and the MOSFET is used for high power application. It is used in power supplies, etc. Thank you.